Good afternoon. Welcome to the research paper presentations presented by Major League Baseball. My name is Harry Kanan, and I'm a member of the Sloan research paper team. And it's my pleasure to introduce Anthony Fowler, who will be presenting How Much Do Coaches Matter? The presentation will last 20 minutes, after which we'll have a 5-minute Q&A session. If you're interested in asking a question, please raise your hand during Q&A, and I will provide you with a microphone. Now, please join me in welcoming Anthony.
Great. Thank you so much. As Harry said, I'm Anthony Fowler. My co-author is Chris Berry up here in the front row. We're both from the Harris School of Public Policy at the University of Chicago. We're political scientists by training, but we enjoy sports, and so that's why we're here, and we're going to talk to you about coaches. So as you probably know, there are big debates in lots of communities about the extent to which leaders matter within an organization, within a company, how much do political leaders matter. And so Chris and I have both been studying this to some extent, and we realize that the methods we're using are applicable to sports coaches as well. So we have lots of anecdotes about leaders in general and about coaches. We know there are some coaches that have great careers and some coaches that seem to struggle, and we don't know what to make of those anecdotes, right? It could, of course, be that some coaches are just lucky or unlucky. They were there at the right time or they were there at the wrong time. And what we want to know is, can we assemble some systematic evidence to tell us how much coaches really matter? Does it really benefit you to have a good coach versus a bad coach? And what proportion of variation in a team success can we attribute to, can we give credit to the coach for that success? One challenge that we have empirically when trying to answer this kind of question is that we know there should be serial correlation in outcomes for reasons unrelated to coaches. Some players are better than others, some organizations are better than others, they have better funding and so forth. There's all kinds of reasons why some teams might have a good run of years even if coaches don't really matter. And so we want to figure out a way of teasing out coach effects from that possible serial correlation. Our specific approach we call randomization inference for leader effects, RIFLE, and it's a method that we've developed to solve precisely this kind of problem. So to the extent that there is systematic empirical evidence on coaches, a lot of analysts have concluded that actually coaches don't matter that much, and they might for the most part just be interchangeable with one another. One reason people have concluded that is if you look at historical data, teams don't tend to do better or worse when they switch coaches. So on average, switching coaches doesn't necessarily help a team, doesn't necessarily hurt a team. Of course, in and of itself, that doesn't tell you whether coaches matter or not. It could just be that sometimes the new coach is better, sometimes the new coach is worse, and on average, there isn't much change, even if, in fact, coaches do matter a lot. And so what we want to know is we want to answer a slightly different question, not do coach changes matter, but are some coaches meaningfully different than other coaches? So here's the basic idea of what we're going to do. We're going to run a regression where we include a variable for every coach, a fixed effect for every coach. And then we're going to get some fit statistic like an R-squared. And that R-squared will tell us how much variation in outcomes do coaches appear to explain. Now there are 3 reasons why you might get a high R-squared from a regression like that. One of them is that there could be coach effects, and that's what we'd like to estimate. But there are these problems, there are these confounders. It could also be that there's just lots of serial correlation, so it looks like coaches matter when they don't. Or it could be that you're just overfitting to random noise. And so we'd like to have a strategy that removes those second 2 factors and identifies the first factor. And what we're going to do is we're going to do a series of random permutation tests to try to isolate out that first factor so that we can know how much would the second 2 factors how much R-squared would those produce on their own in the absence of coach effects. So I'll try to get into a little bit more detail about how we're going to do that in the next slide. So here's a very broad overview of what we actually do, what RIFLE is, and just in case anyone's interested, we have a data package where you can download RIFLE and start using it yourself on your own data, your own outcomes of interest. We would love for you to do that. So the first step is to just prepare the data for analysis. There's a lot of different choices you have about how to do this, but for us, in most of our settings, we're going to try to generate season-level data, so team-by-season level data. We're going to adjust for opponent quality, adjust for home field advantage, residualize out all the factors that you think don't relate to coach effects, but might help you get rid of some of that extra variation. Then what we're going to do is, like I said before, we're going to run a regression of that residualized data on coach fixed effects. So there's a separate variable for every coach in the data, and then we get some fit statistic like an R-squared. Then, of course, like I said before, that R-squared in and of itself isn't all that informative. What we're going to do is we're going to randomly permute the coaches. So just imagine there's a team where there were 10 coaches that served. One guy served 10 years, one guy served 5 years, another guy 3 years, etc. We're going to randomly permute the orderings of those coaches. For each randomly permuted ordering, we're going to rerun that regression. And we're going to record that pseudo R-squared that we get from that regression. And we're going to do that over and over again, thousands of times. And we're going to see the distribution of R-squareds that we get across all of those different random permutations. What that gives us, and we can talk about this in a little more detail, what that gives us is a distribution of R-squareds that you would expect in a world with no coach effects, but in a world where you do have serocorrelation and overfitting of random noise. And then we're going to compare the real R-squared from the real regression to the distribution of the permuted R-squareds. And that's going to allow us to statistically test whether coaches matter in that setting and for that particular outcome of interest. So here's an example of this in practice. So we've done this for Major League Baseball. One outcome we've looked at is runs allowed, and that turns out to be one where managers really matter a lot. The red line shows you the real R-squared from the real regression, and then the histogram on the left shows you the distribution of R-squareds you would expect under all those different permutations. And in those permutations, of course, that's giving you a sense of the null in the world in which coaches don't matter at all. And the real R-squared is notably higher than any R-squared you get from any of the permutations. So the fact that you get such a big difference there suggests to us that, one, we can strongly reject the null that managers don't matter for this particular outcome. And two, they probably matter a lot. And the extent to which that red line is bigger than the mean of that distribution is going to tell us something about the actual effect size. And then on the right, you can see an example where we actually don't find much evidence that managers matter. And that's on the outcome of wasted runs, which I can come back and talk about in another minute. Can we slide forward? Okay, thanks. So why does this particular test work? I hope I've given you at least some of the some sense of the logic of why we're doing this. In these permutations, so the only thing that's different in these permuted regressions is that the ordering of the coaches is different. Everything else is the same. The number of coaches, the distribution of their tenures is the same, et cetera. So what that means is that to the extent that serocorrelation affects the R-squared, or to the extent that overfitting affects the R-squared, it should do so in the same way in both the permuted regressions and in the real regression. However, to the extent that coach effects affect the R-squared, they should affect them a lot more in the real regression than in the permuted regression. So all of our identification comes from the fact that different coaches are serving different periods of time. So if every coach served 5 years, we wouldn't have any identification here because the permuted regressions would be the same as the real regression. So all the identification comes from that, and we're checking to see whether or not variation in the outcome seems to coincide with the tenures of coaches. That's the intuition here for why this works. We've done a number of simulations, a number of Monte Carlos that we can talk about in more detail if you have questions to assess the properties of this strategy. It works very well. It does indeed account for overfitting. It does indeed account for serocorrelation, and we can talk more about those if you're interested. Okay, so having developed this method, we've applied it across 6 different sports settings. We're looking at the Major League Baseball, NFL, college football, NBA, college basketball, and the NHL. And all of our data is from Sports Reference. You can look at the time periods here. For the most part, we're looking at very large samples of data, essentially the entire history of the Major League Baseball, essentially the entire history of the NFL. We've cut these up into different time periods if you're really interested. We actually don't find a lot of differences, but we can talk more about that if you're interested. So let me just show you some of our results, and you can see what kinds of things you can do with this. We've certainly not done an exhaustive analysis of each of these sports settings, but we want to give you a sense of the kinds of things you can learn using Rifle. And if you have your own outcomes, your own settings that you want to study, we would love for you to do that yourself. Before I show you some of the results, let me just show you what the level of statistical power is that we have with our tests. So for each of those 6 settings, we've estimated a power curve. We've simulated some fake data, and we said, let's suppose that coaches affect, say, 30% of the variation in their team success. And we'll simulate some data with that true effect size. How often will we reject the null? How often will we get a p-value less than 0.05? And you can see what those power curves look like across these 6 settings. We obviously have more power for college basketball and college football because we have so many more teams and we have a lot more data there. But the power is pretty good across all of these settings. As long as coaches affect 20% of the variation or so, we're very likely to reject the null. But our test is not so powerful as to detect small effects of coaches on the order of 2, 3, 4, 5%. So that's the level of power that we have here. And then we can also learn something about, if we can click forward, we can also learn something about the effect sizes. So having done those same simulations, we can ask, okay, suppose coaches really affect, really explain 20% of the variation or 30% of the variation. What would we expect the difference between the real R squared and the permuted R squareds to be? And having done these simulations, we can then take our results and we can then back out what do we think the real effects of coaches are. So say we get a real difference in R squared of say 0.1, we can look at a curve like this and say, therefore coaches must explain this share of the variation in the outcome. So that's how we're getting these results. Something terrible happened. Can we get to our results slide, perhaps? Sorry about that. So if you just keep, or I can do it. I can try. What you're going to see next are the results for Major League Baseball. There we go. Perfect. And for each of these graphs, we're just plotting for you the effect size here, the estimated effect size, the proportion of variation that appears to be explained by coach effects using our test. So using that strategy that I described before, a solid dot is an estimate that's statistically significant at the 0.05 level. Many of these are much more significant than that, something like 1 in 1,000. And a hollow dot is one that's not statistically significant at the 0.05 level, where we cannot confidently reject the null that coaches don't matter. So what you see here for Major League Baseball is that managers do appear to explain a lot of the variation in baseball. Something on the order of 20 to 25% of the variation in the success of a team is attributable to the managers, although managers appear to matter more for runs allowed than for runs scored. To us, that makes some sense. We think there's more strategic decisions for a manager to make in terms of pitching than for hitting. Right? When you're hitting, you're largely just putting your best hitters in the lineup, and most managers doing largely the same things. Whereas when it comes to allocating your pitchers, there are more interesting strategic decisions to make, and it's not surprising that some managers are better at that than others. The last outcome that we looked at that I showed you earlier was wasted runs. There are baseball experts who have told us, who claim, and maybe some of you feel strongly about this in either direction. There are baseball analysts who claim that to the extent that managers matter, they should really matter by allocating runs across games. Maybe there's only so much you can do to score more runs or allow fewer runs, but what you can do is you can smartly allocate your pitchers so that if you know this game is a foregone conclusion, you can just cut your losses and you can save your good pitchers for the next game. So that's why we've calculated this wasted runs variable to see if maybe some managers are just better at saving runs and allocating them across games. And actually, we don't find much evidence for wasted runs. To the extent that managers matter, we find they matter a lot for runs allowed, and which of course translates into point margins and victories. Okay. So we've also looked at the NFL. For all of our settings, we can, of course, look at points scored, points allowed, point margin, and victory. Those come just from the actual results of the games. And then in some of our settings, we can look at other outcomes of interest as well. So in the NFL, we also get relatively large effects, something on the order of 20%. Coaches explain roughly 20% of variation in their team successes. Again, for the NFL, we find that coaches matter more for defense than for offense. The results, the difference is not huge, but there is a difference there. We've also looked at some other outcomes of interest in the NFL. We've looked at fumbles. Coaches matter a lot for fumbles. They matter a lot for penalties committed by their own team. They don't matter at all, it seems like, for forcing penalties by their opponent. And they perhaps surprisingly don't actually differ all that much in terms of passing versus rushing. So this last outcome here is what proportion of offensive plays are you passing versus rushing? And it turns out that coaches don't actually meaningfully differ much from each other on that dimension. Of course they could, but they don't. In the case of college football, we again get very large estimates, even larger than we get for the NFL. That might make sense in the sense that for college football, coaches have all of the same roles they have for the professional level, with the addition that coaches are also perhaps more important in recruiting players. And so maybe it makes sense that coaches are have even greater effects in college than they do at the professional level. For basketball, for the NBA, we actually get our biggest estimates for both the NBA and for college basketball. These effects are on the order of 30%. Coaches explaining in some cases, a third of the variation in the success of their teams. And the results look pretty similar for the NBA and for college basketball, with this additional caveat that in college basketball, there's a very big difference here if we look at total points. Coaches actually exert huge effects on the total number of points scored in the game, perhaps suggesting that some coaches just prefer a fast-paced game where they score a lot of points and allow a lot of points, whereas there are other obviously slower-paced coaches who do the opposite. And then lastly, we've looked at the NHL. Admittedly, Chris and I are not experts on the NHL. We learned most of what we know about the NHL about face-offs just now from the last presentation. But if you have things that you know about hockey where you think we should face-off wins, we're going to include that as our next outcome. But if you have other outcomes that we should be looking at, we should look at them. Coaches appear to matter a lot in the NHL as well, and they also seem to matter more for goals allowed than they do for goals scored. So we have a number of extensions in the paper that I'm not going to take the time to explain here in detail. One of the issues that we dedicate some attention to in the paper is the issue of endogenous retention. Obviously, it's not random which coaches are serving at which periods of time. You're more likely to fire the coach when they've had some bad seasons. You're more likely to retain them when they're doing well. And so we explore the implications of that for our test, and it turns out those implications turn out to not be very significant, which is good, but we can talk more about that if you're interested. We also have some discussion of the difficulty of statistically studying an individual coach. All we've shown you so far is that coaches matter. Some coaches are better than others, and differences between coaches explains a lot of variation in outcomes. We haven't told you which coaches are the best coaches, nor do we have strong, statistical way of saying which ones are the best ones. If I take any individual coach, even if you've had a pretty good run of, say, 5, 6, 7 seasons, I have to ask myself, how likely is it that some coach somewhere might have just had a good run of 5, 6, 7 seasons just by luck? And the answer is that's actually pretty possible. If we run a lot of simulations where coaches don't actually matter, you're going to find coaches that look like they matter, that look like they're having really great runs, and so you won't know for sure if you have a great coach or not. But of course, if a coach has served a long period of time like Bill Belichick, then you probably can, in fact, reject the null that Bill Belichick is not just your run-of-the-mill coach. And so this graph here is a statistical test of Bill Belichick's effectiveness. We've conducted simulations and we asked, what are the odds that you'd have a coach like Bill Belichick who over a period of 17, 18 seasons had this good of a run? And the answer is it's virtually never happens, suggesting that Bill Belichick probably is not just your run-of-the-mill coach. But in general, this is a hard question to answer because we just don't have enough data for individual coaches. And the last point that I want to make is that this method, I hope you can see, is relatively general. It's applicable to virtually any sports setting, applicable to virtually any outcome of interest. If you're interested in coach effects, you can download our Stata package. You can start using it right away. You can give us suggestions for other outcomes we should be looking at. So thank you so much for your time.
Thanks. Any questions?
So when do you say coaches, do you mean just head coaches, or do you include some like linebacker coaches, like offensive coordinators?
So all of our analyses are focused on the head coaches. To the extent that you might think other coaches matter, linebacker coaches matter, offensive coordinators matter, you might want to give some of that credit to the head coach because the head coach is largely the person who hires that person and manages the entire staff. And so that's primarily the way we're thinking about it. We're not separating the effects of different coaches, but we're asking how much does the leader of the organization matter.
Thinking about how this kind of role, especially when you think of a coach, is one that has a lot of high turnover in it. Mm-hmm. Based on what you've seen, what would you say is the minimum amount of time you'd want to be able to really trust information you're seeing about whether a coach is actually affecting a team? Especially when you think about, for example, I think of the English Premier League, that very quickly, maybe a coach has maybe 10 games. Mm-hmm. How long do you think would you expect you would need to be able to really assess whether a coach is actually having an impact or not?
So there's one part of the question that I can answer with some confidence, which is if you were just looking at the outcomes of the coaches, if you were just looking at the game outcomes and trying to infer whether you had a really great coach or not, you would have to wait at least 4, 5, 6, 7 seasons before you were likely to reject the null that this coach is actually better than your average coach. So that's obviously a long period of time, and most teams aren't willing to wait that long, perhaps. If you had other information, obviously there could be qualitative information that could be informative. We have not obviously done that analysis to know. Maybe there's other ways of observing coaches to figure out whether they're effective, but just by looking at their game outcomes, you would need a lot of data before you could confidently conclude that a coach was much better or worse than average. Maybe there's, organizations have more information than we do just by looking at the scores of the games, obviously. But if you were just going on performance, you'd want to give it some time.
Hi, I have two questions. The first one is, you obviously covered a long period of time for your study. I'm wondering, is there any temporal effects on the coaching? For example, basketball played in 1947 is different played in now, right? More and more threes pump out. Is there any justification on that part? The second question, we are talking about the coaching, but how about the players? I mean, Belichick without Brady would still be successful now? Do you just adjust any of the player effects in this simulation?
Sure, so the first question was about over time differences. And perhaps surprisingly, we actually don't find really big differences across time. We've cut up some of the sports into different eras, and perhaps surprisingly, the estimates are pretty similar. So we have a very long period of the NFL, right, that goes back to 1922. If you just look at the modern era of the NFL, the estimates are very similar to what we get looking at the overall period, and that's true. That's true in most of the sports. We've also cut up the data in different ways. You can separate the American League and the National League. You might think that the effects are bigger in the National League than the American, but actually they're pretty similar. So we've done a lot of that, and we've been surprised at how consistent that 20, 25%, 30% number is, depending on the setting. And then your last question was about player ability. Player ability is obviously incredibly important, although I would give a similar answer that I gave about, say other coaches, which is that to the extent that Tom Brady is a great quarterback, I don't know how much credit I should give to Bill Belichick for that or not. But surely I should be giving some of it to Bill Belichick because good coaches make their players better. And so we have not made any effort to partial out the effects of players, partly because to the extent that coaches are there when there's good players, we might want to give them some of the credit for that. And of course, obviously, our method implicitly is accounting for that, because to the extent that there's just good players that create zero correlation, that's true in the permuted data as well, right? So we have a kind of implicit way of controlling for that. We haven't done it explicitly.
Great. Well, thank you very much.
Okay, thank you.